Hi everybody and welcome to our demo video for our demo track paper on an open source framework for closed loop multi-UAV planning and execution. I'm Nico Michel, a researcher at the University of the Bundeswehr Munich, Germany. Nowadays, drones are very popular, for example in search and rescue missions. However, operating multiple UAVs at the same time entails substantial labor overhead. Furthermore, current multi-UAV mission planning systems impose hardware and software logins, as only few commercial suppliers provide such systems. This hinders the integration of heterogeneous UAV platforms as well as cutting-edge AI planning techniques. Therefore, our aim is to combine UAVs with heterogeneous hardware and software in one framework, allowing us to utilize various UAVs in one mission. We want to adopt a modular design for flexible integration of AI planners and execution logics. This provides a research platform as we make our framework publicly available to facilitate extension and reusability of the modules. The case study in the video depicts a search and rescue mission, mainly inspired by rescue organizations, but our framework can be adopted to various operators of UAV swarms. To enable this, we use our holistic, modular, open-source decision-making framework AUSPEX, which is a multi-agent system combining a ground station with multiple UAVs. It is tailored to host state-of-the-art decision-making frameworks and enables closed-loop planning and execution. The ground station hosts the planning module, which is the core module of AUSPEX. It includes unified planning, a state-of-the-art planning framework. Furthermore, the ground station includes the executor as well as the knowledge base and the sensing module. Via ROS2, the UAV's AUSPEX Aero module are connected. For the present use case, we use 3 UAVs. The largest UAV is the multicopter MK-U20, which is able to fly for about 40 minutes. It comes with a Cube Orange Plus flight controller running AutoPilot and uses a NVIDIA Jetson Xavier NX as offboard controller. It carries a high-quality camera system with a wide angle and a thermal camera. The smaller UAVs are HolyBro X500 version 2, which are using a Pixhawk 6C flight controller and a PX4 autopilot software. We use a Raspberry Pi 5 as offboard controller and attached a portrait camera looking downwards. The different drones underline our system's ability to work with heterogeneous hardware and software. Where all UAVs are equipped with a camera, one HolyPro is carrying a first aid kit. All UAVs are connected via surf sticks to the cellular services and are in the same VPN network as the ground station. You can see the video streams of the UAVs in detail, with the wide angle and the thermal camera of the multicopter at the bottom. Our example scenario is inspired by a typical search and rescue mission. We need to locate a missing person represented by a dummy. Further, we want to deliver a first aid kit. You can see our GUI or GUR where the UAVs are popping up once connected to the system. In our GUR, the operator can define the search area as well as no-fly zones to enable a safe operation. The planning module is automatically assigning the UAVs to each search area. Once the mission is started, the UAVs are automatically taking off and flying to their search area. The real-time UAV motion is displayed in our GUR. Now you can see the UAV's video stream and the progress of the search. Here, the UAV is detecting the target via an object detection model. Afterwards, its position is added to the map. The UAV, equipped with the first aid kit, is taking off and delivering it to the target position. In the meanwhile, the other UAVs are returning. You can see the drop of the first aid kit here again from an operator's perspective. As the mission is now completed, all UAVs are returning to their home position and are landing. Thank you very much for your attention.